All right, question 1. We have for part A, simplify m squared to the power of 3. So what do we do when we have this situation? We just multiply those numbers. So we do m to the power of 2 times 3, which is m to the power of 6. Next one, what do we do when we are multiplying? We add the powers. So we do x to the power of 5 plus 8, and that gives you x to the power of 13. There you go. Part C, expand 4p bracket p squared plus 3p. What do? We just expand by multiplying like that. So we had 4p cubed plus 4 times 3, that's 12, and then p squared. Okay. Question 2, Johnny wants to know how much coffee he will need for 800 people at a meeting. Each person who drinks coffee will drink 2 cups of coffee. 10.6 grams of coffee is needed for each cup of coffee. Johnny assumes that 68% of the people will drink coffee. Using this assumption, work out the amount of coffee Johnny needs. Give your answer correct to the nearest gram. Right, so if we go and highlight some key parts of this question, so the first thing that stands out is 800 people at a meeting, and each person who drinks coffee will drink at least 2 cups of coffee, and 10.6 grams of coffee is needed for 1 cup, for each cup of coffee. Okay, and then Johnny makes an assumption. He assumes that 68% of the people will drink coffee. So by using this assumption, work out the amount of coffee that he needs. Right, so if we start off with step number 1, 68% of the people of 800 people. Okay, so let's find that. What is 68% of 800 people? Whichever way you use, guys, you could do 68 over 100 times by 800, or you just use a multiplier for 68, which is 0.68 times by 800. And that gives us 544 people. So this is the number of people that are assumed to drink coffee. Okay? Okay, assumed to drink coffee. Step number 2. Johnny says that each person who drinks this coffee will drink 2 cups. So therefore, the 544 people will drink 2 cups of coffee. So 544 times by 2, and we get 1088 cups of coffee that is assumed to be potentially drunk. Okay. So step number 3 now is, if in 1 cup of coffee you need 10.6 grams of coffee to make 1 cup of coffee, and you are going to need to make at least 1088 cups of coffee, then step number 3 would be to multiply the 10.6 grams by 1088 cups of coffee, and that gives us 11,532.8 grams of coffee. So this is the amount of coffee that is needed. Okay, now the question says, give your answer correct to the nearest gram. So right here, the nearest gram would be to round this up to 3. So it would be 11,533 grams of coffee to the nearest gram. And that's your answer. Now, part B of the question says Johnny's assumption is wrong. 72% of the people will drink coffee. So what was the assumption again? He assumed that 68% of the people will drink coffee, but actually it's going to be more than that. So more people will drink coffee. If more people, that's 72% of 800, right? We don't need to work out anything because it's only for 1 mark, okay? We just want to answer, how will this affect our answer to part A? How will this affect that? What will happen? So if more people are going to be drinking coffee, that means you need more cups of coffee, all right? And therefore, you're going to need more grams of coffee as well. So the number of, you need more coffee. You need more coffee in grams to serve 72% of the people drinking coffee. Okay, so basically, how will this affect your answer? You could also say it will increase. You could just say it will increase. Okay, that's probably more straightforward. And it's only just for 1 mark anyway, so examiners just looking for that word increase or more, and you've mentioned it in either way. All right, question number 3, we have to show that the triangle ACD is isosceles. So where's ACD? ACD, we have to show that this triangle is an isosceles triangle, and we have to give a reason for each stage of our working. Right, so obviously what is an isosceles triangle? Let's quickly just remind ourselves. It's where 2 sides are the same and these 2 bottom angles right here are the same. So that's all we have to prove. So if we just prove that this angle here perhaps, or this angle here, it depends on which way it is. I'm not saying that these are the 2 parallel sides, by the way. It could be that these 2 are the parallel sides and these 2 angles are the same. Okay, so don't always think it's this way up. All right, it could be on its side. All right, but basically we just need to find that 2 angles here are the same. Okay, so either these 2 or these 2 or these 2. Okay, let's see. Right, we can actually find this one right there. Can you see? We can start off with that because that is a straight line. So let's go ahead and find that angle. This would be angles on a straight line. So therefore this would be 180, take away 110, and that gives us 70 degrees. So that is 70 degrees. And the reason, we have to give reasons, remember, angles on a straight line. So let's write the reasons down. So angles on straight line. Okay, there. Right, what's next? Right, can you see here? You've got parallel lines right there. So all the rules pertaining to parallel lines we can use. So right there you have an intersecting line there. So this is 125. What can we say about this angle right there? Does that remind you of anything? The Z angle. All right, you got the Z angle right there. A Z right there, alternate angle. Yeah, I should be using the official terminologies actually. So that's 125. All right, so that is 125 degrees. Why? It's an alternate angle. So you could say something like angle FCD is 125, and why? The reason is it's an alternate angle. Okay, right, with the same rule that we use up here, we can find this now, can't we? Okay, this would be angles on a straight line again. Okay, so we can say that this angle right there would be 180, take away 125, and what does that give us? That gives us 55 degrees. Right, so that now leaves us with one angle to find on our triangle, and we can just use angles on a triangle to find that. Okay, so to find this angle right here, we do, let's label this angle actually, so we can call it CAD. Okay, we're going to call it CAD. So angle CAD, how do you find it? You do 180 because angles in a triangle add up to 180, right? All these 3 angles add up to 180. So you do 180, you add up the 55 plus the 70, and that is 180 minus 125, and that gives us 55 degrees. So now we have proved that this is 55 degrees. And look at that. You've got this angle and this angle, which are the same. It's met this criteria of an isosceles triangle. So therefore you have proved that you have an isosceles triangle. So therefore, isosceles triangle, because angles CAD is equal to angle ACD or DCA. Okay, there you go. And also, before you forget, you should give the reason for that last one here. So angles in a triangle. Angles in a triangle add up to 180. Okay, so that's my reason for the last one. Because it says give a reason for each stage of your working. And that was for 5 marks. Right, question number 4. It takes 14 hours for 5 identical pumps to fill a water tank. How many hours would it take 4 of these pumps to fill another water tank of the same size? So if we write down 14 hours is equal to 5 pumps, we are trying to work out what? How many hours it would take for 4 of these pumps to fill another water tank of the same size. So 4 pumps, that's what we're trying to work out, what 4 pumps would be. How long, how many hours? So that's my mission. So I need to find a way to get down to 4 pumps. So what I could first start off by doing is going to 1 pump. All right. So how do I do that? How do I get 5 to be 1? I divide by 5. On the other side, it's going to be an indirect proportion, because if I'm reducing the number of pumps by dividing by 5, if I divide this by 5, that would be 14 divided by 5, give me a smaller number, right? Which I can't have. It doesn't make sense that 1 pump would pump water in less amount of time, okay? This is indirect proportion. So it's going to be the opposite. Okay, you're going to be timesing by 5 on the other side. Okay, so what's 14 times by 5? 14 times by 5 is 70. So 70 hours is what is needed for 1 pump to fill the water tank. Now, I want to go back up here. So by timesing by 4, I will go up to 4 pumps. So if I times this by 4, I will get 1 times by 4, give me 4 pumps. But on the other side, once again, it's indirect proportion. All right, so I'll do the opposite. I'll be dividing by 4. Okay, so 70 divided by 4, can get rid of this question mark now. 70 divided by 4 is 17.5 hours. So 17.5 hours is what's needed. So 17.5 hours is what's needed for 4 pumps to fill another water tank of the same size. All right, question 5. A and B are numbers such that A is equal to that, B is equal to that. Find the highest common factor of A and B. Right, so where do we start? So before I do that, I'm just going to make a quick copy of that because I'm going to need it. Right, so now we are going to highlight the common values that they both have, common numbers that they both have. Now, can you see here, this has got 2 squared, all right, but this one doesn't have any 2. So that's not common, all right? This has 3 to the power of 4. This has 3 to the power of 2. So the minimum that we can take out is 3 to the power of 2. That's common to both of them. All right, that's the minimum. So I'm going to highlight that. Okay. This one's got 7. This has got 7 squared. So the minimum is 1, 7. So I'm going to highlight the 1, 7. So what do we have now? We've got 3 squared times 1, 7. And if we calculate that, that's 3 times 3 times by 7. That gives us 63. So 63 is the highest common factor. Now, another way you could have done this is you could have put this into a Venn diagram if you wanted to. So you could have had 2 circles. And I'll quickly show you that as well, because some of you might want to use this method. You can have your A and your B here. So what you're looking for in the Venn diagram, you need to put the numbers in the middle, which are common to both of them. All right, so can you see here, the minimum that they both have is 3 squared. Okay, that's the minimum that they have, yeah? So you could write 3 and 3 right there. 3 times 3 is 3 squared. And then they have 1, 7 that is common between them. Okay, so this has a 7, this has a 7 squared, so 1, 7 goes in there. Now, right, this one, A, just A, has 2 2's. So 2 2's like that. Also, A has an extra 2 3's, because this one only has power of 2. Okay, so you need to put that in there. So 3 and 3. And B on its own exclusively has an extra 7. So that's that. So again, what are you looking for? You're looking for the highest common factor, which is basically those numbers right there, which is the same numbers here. So 3 squared times 7, which is 63. Okay. Now, if we go into the lowest common multiple, okay, we can do the same thing again, all right, that we did above there. So we can take that diagram, because we've already got it filled in. We don't need to do it again. All right. And what we're looking for this time? Well, the LCM is all the numbers, okay, multiplied. All the numbers multiplied. So we have 2 squared. We have 3 to the power of 4. So let's write them down. 2 squared times 3 to the power of 4 times 7 squared. Right there. Okay. So that would be the LCM. You've got a calculator to use. If you put that into your calculator, you get 15876. And that's your LCM. And you could, of course, have done it without the Venn diagram. So you could have done just like 2 squared, because this one doesn't have a 2 squared at all. The B doesn't have the 2 squared. And then you could have selected your 3 to the power of 4, because that's the largest, and it also takes that into consideration. And the last one would be 7 squared, which is this one, because it already takes this one into consideration. Okay, so you could just multiply those for the LCM if you wanted to do it that way. Question 6. Lava flows from a volcano at a constant rate of 11.9 meters cubed per second. How many days does it take for 67,205,600 meter cubed of lava to flow from the volcano? Give your answer correct to the nearest day. Wow. Right, big numbers here, literally. So where should we begin? First of all, look, you've been asked for the nearest day. Okay, make a note of this, and this is in second. The flow, the rate of flow, okay, is in second. Okay, so be mindful of that. Don't get tricked by that. Let's just quickly highlight it so we remember it. We are looking for what? We are looking for how many days does it take? Okay, that's it. So because we were looking at this day and second thing earlier, let's do the conversion for that. So in one day, okay, there are 24 hours. And in 24 hours, we just multiply this by 60, okay, we can get it into minutes. So 1,440 minutes, okay, in 24 hours. And to get that into seconds now, minutes into seconds is to times by 60 again. We get 86,400 seconds. Okay, so now we know that in one day there are 86,400 seconds. So that's the first thing that we write down. Now our first step after that would be what? We need to work out the rate of flow. So if we want to get this much lava flowing from the volcano and work out how many days it takes, we're going to need to do this divided by the rate that is flowing at, okay, which is 11.9. So we can do 67,205,600 divided by 11.9. And if we put that into our calculator, we get 5,647,529.412. So this is how many seconds are needed for filling this much lava from the volcano. Okay? Now, that's in seconds. We now need to just convert that amount into days. And how do we do that? Well, earlier on, we know that in one day there are this many seconds, so we can just divide that by that number. So 5,647,529.412 divided by 86,400. And that is 65.3649 ... And to the nearest day, because the question asks for the nearest day, that would be 65 days. Now, if you did say, a day higher, because obviously some could argue that it's 65 days 0.3, so therefore you need an extra day. You probably 66, you'd get away with that as well. All right, question number 7. Here is a graph. Y is equal to x squared minus 2x minus 2. Write down the coordinates of the turning point. All right, let's zoom into this graph. What's a turning point? Turning point is literally where the graph is turning to a new direction. Okay, it's right there. We just need to give that point right there. Okay, so how do we do that? Well, we just go and read across. Our x value for our turning point is 1 right there, and our y value is minus 3. So our turning point is 1 and minus 3. So we can go back to the question and say the turning point is 1 and minus 3. Part B, it says write down an estimate for one of the roots of this graph or the equation. What are the roots? The roots are where it cuts the x-axis, right? This is the x-axis. The roots are where the graph cuts it, which is at 2 points. One right there and one right there. Again, we just need to work out what the x values are. Okay, that's what the roots are. Okay, let's work this one out first. We can see here we've got 2 and 3, and we've got 1, 2, 3, 4, 5. Okay, so that's 2.2, 2.4, 2.6, 2.8, and 3. And it's between 2.6 and 2.8, which is 2.7. So we can say right here that x is equal to 2.7. That's one of our roots. If we go to the other one, do the same thing. So it's between, that's minus, by the way, so minus 0.2, minus 0.4, minus 0.6, minus 0.8, and we've got minus 1. So it's between minus 0.6 and minus 0.8, which is minus 0.7. We can just go with that because it's an estimation at the end of the day. So x is equal to minus 0.7. And there you go. These are two solutions. So we can say now that x, one of the roots. Okay, so it's just one of the roots, guys. You don't need to give both. So you could say x is 2.7 as one. Or if you want to give the other one, you can say that is minus 0.7. Okay, but you just need one. All right, that's why it's only 1 mark. So one or the other is fine. All right, question number 8. A solid cuboid is made of metal. The metal has a density of 9 grams per centimeter cubed. The volume of the cuboid is 72 centimeter cubed. Work out the mass of the cuboid. Right, so we have a density question here. So the first thing I want to write down is the formula, which is density is equal to mass divided by the volume. All right, that's something I always do. If I recognize that I'm going to need certain formulas, I'm just write them down straight away. Okay, then it's there for me and I can manipulate it and start thinking about it as I'm reading the question. So what does the question want me to do? Work out the mass of the cuboid. So clearly I'm going to need to make mass the subject at some point. In fact, let's do it now. So what is mass? Mass is equal to, if I rearrange that using the triangle, I know a lot of you struggle with this, so that's mdv. If I'm looking for the mass right there, I hide the mass. What am I seeing here? I'm seeing d times v. So mass is equal to density times your volume, and the density is in the question right there. That's 9. So that's 9 times, and the volume is in the question. The volume is 72. So 9 times 72, and that is 648 grams. So the mass is 648 grams. Question 9. Some people were asked if they wanted a new TV. 70% of the people said yes. 80% of the people who said yes wanted a TV with a large screen. What percentage of the people asked said they wanted a television with a large screen? All right. So we know that 80% of the people that said yes, and how many people said yes? 70%. So 80% of the 70%, all right, wanted a large screen. Let's write it like that. Wanted a large screen. Okay. So once again, look, 80% of the people who said yes, and how many people said yes? 70%. Okay, so we're looking for 80% of 70, because 80% of 70 are the people that wanted a large screen. Okay, that's what I've written that down here for. So 80%, the multiplier is 0.8. Of means times, and the multiplier for that we're not going to use because we want to find the percentage of 70%. Okay, so we're just going to keep it as 70%. So 0.8 times by 70, what does it give us? It gives us 56%, which means 56% of the people wanted a TV with a large screen, and that's your answer. All right, question 10 for 3 marks here. ABD is a triangle, C is a point on B to D, and work out the length of DC. Give your answer correct to 1 decimal place. So what we're looking for, we're looking for that length right there. As you can see, we've got 2 right angle triangles that we can deal with. All right, so step number 1, what can where do I start from? You see, if I go to this triangle first and try to work out DC, I have an angle, but I don't have this side here. I don't have this side, nor do I have this side, nor do I have that side. I have no sides. So what I'm going to do here, I'm going to use the other triangle, right, and find at least that side, because this other triangle has the angle and has a side. So step number 1, I'm going to draw the other triangle right there. We know that this is 41, this is 6.8 centimeters, this is A, this is C, this is B. Okay, so we can find the side A to C. Okay, or we can find C to B. It doesn't actually matter, but this is, you know, more important because that is the side I need, and then I can use this triangle to find this side. Okay, so how do I find that? What do I use to find that? Trigonometry. This would be the hypotenuse, and this would be your opposite. So if I use my SOHCAHTOA, what uses hypotenuse and opposite? It's sine. So I'm going to do sine 41 is equal to the opposite, which is x, or I can call it, by the way, a to c. Probably easier, a to c, because look, I can call it x or a to c. Okay, a to c over 6.8, so 6.8, and then I rearrange that in terms of a to c, so I take the 6.8 and multiply it to the other side. So that becomes 6.8 times by sine 41. Knock that into my calculator and I get 4.46 centimeters if I round it to 2 decimal places for now. And now step 2. Okay, step 2 would be now to say, look, I know you are now 4.46 centimeters. So now I'm going to use this triangle right there and calculate D to C. Okay, so let me draw it out. So there's the other triangle right there. So that is 4.46, which I just found. That's C, that's A, that's D, and that's 55 degrees. Okay, so I'm looking for the length of D to C. So I can put an X right there. Again, I'll label it according to trigonometry. So that's the opposite side. I'm looking for the adjacent D to C. So if I go back to SOHCAHTOA, what uses O and A? Tan. Okay, tan uses O and A. So therefore tan 55 is equal to opposite, which is 4.46, divided by the adjacent, which is DC or X. I'm going to call it DC. Okay, and then I just need to rearrange that. Now, some of you guys may struggle with rearranging this. Again, you can use the triangle. Okay, the triangle method very quickly. What goes on the top? On the top is 4.46 because that's the division bar. This is the division bar. Okay, what goes on the bottom? Tan 55 and DC. We are looking for DC. We want to cover up DC. What we're seeing here, we're seeing 4.46 divided by tan 55. So DC would be equal to 4.46 divided by tan 55. Knock that into your calculator and you get 3.12292 ... If we round it, what's it ask? Just 1 decimal place. So D to C to 1 decimal place is 3.1 centimeters. 1 dp. And there is your final answer. All right, question number 11. The table shows some information about the heights of a group of adults. Now, I'm going to have to zoom in and out from this question because I can't show you the whole thing on one page, otherwise it's going to be too zoomed out. So I'm going to go and zoom into the first part first, okay? So what we're looking at here, we have to draw on the grid a box plot of this information right there, okay? So this is median, which is in the middle, the lower quartile and the upper quartile are given. So let's start with that, okay? Let's start with that. So go and find 177 for the median. Let's start with that. So that's 175, this one. We just need to work out each of these. I think 175, each one is worth, each two is worth 1. So that's 176, 77, 78, 79, and 80, okay? So every 2 boxes across is worth 1. Okay, so 76, 77, 78, 79, 80, 180. Okay, so we're looking for 177. So 177, 76, 77, right there. I'm just going to draw it there. Okay, that's 177. Now, so that's that done. The upper quartile, since I'm near there, it's 180. There you go. So that's the upper quartile, and the lower quartile 174. That would be right there. And then I'm just going to close that up like that. Okay, so I've done that. Now the least height and the greatest height. So the greatest height is 186, which is right there. So there you go. And the least height is 169. Right there. There you go. And there you have it. My box plot is done for part A, which is the adults. Now it says the box plot below shows the distribution of the heights of a group of teenagers. All right. and it wants us to compare the distribution of the heights of the adults with the distribution of the heights of the teenagers. All right, now usually these questions have got 2 marks. Let's see. Yes, there you go, 2 marks. So 2 points. And usually these points are to mention something about the median or the range. Could be the interquartile range or it could be the overall range. Okay, so let's see what we have. Can you see the median of the teenagers is, what is it, 169. So the adults median is on average, the average is higher. Okay, so we can say that first. We can say something like the adults have a higher median height. Okay, what else do we have? That's for 1 mark though. Okay, the second mark, let's look at the interquartile range right there. What can we see with the interquartile range? If you do, what's this, 171 and 165. So I'm just going to do a quick calculation here. 171 minus 165, that is 6. So the interquartile range is 6. All right. But if you look at this one, the interquartile range is also 6, because 180 take away 174 here is 6. Both of them have the same interquartile range. I can't really say much about that because other than they're both the same. Usually we're looking for, something distinct. So here the interquartile range isn't good to use. However, if you look at the overall range, look at that. The highest take away the lowest. Who has a bigger range? You can see it just by sight. Okay, you don't need to actually calculate it. But you might want to calculate it actually. So let's do that. So for the adults, it's the range is 186 minus the lowest value, which is 169. Okay, so for the adults, the range is 17. Now if I work out the same thing for the teenagers, the range, their highest is 176, 77, 78. 178 is the highest, minus their lowest, which is 155, 56, 57. Oh, okay. So we have to do 157.5. And that gives us 20.5. So you can see that the teenagers have a bigger range than the adults. Okay, so the teenagers have a bigger range than the adults. So the adults have a smaller range, or the teenagers have a bigger range. So you could say the teenagers have a larger range than the adults. Okay, and there you go, 2 marks. All right, let's move on. All right, question 12. Show that those 3 brackets can be written in that form. So basically to expand those brackets out. Right, what we can do is ignore one of those brackets. You can choose any of them, the first one, the last one, the middle one even. But let's just ignore the last one. So we're going to ignore x minus 5 for now and just expand out the other 2 brackets. So x minus 5 can stay there. Okay, you can stay there. And we are just going to expand those out like that. Okay, so what do we get? I'm also going to collect the like terms as well. So I'm going to expand and collect the like terms together. So the first thing, guys, is we get x times x, which is x squared. Then we get x times 3, which is 3x. And then 1 times x, it's a negative. So 3x minus an x is 2x. So plus 2x. And then we get minus 1 times by 3, which is minus 3. Okay, so I've just collected the like terms, okay, as well. So don't get confused. Next, we expand that out now with the bracket that we were ignoring. So each of these terms individually will get multiplied. Okay, last one will be that. So x squared times x, what do we get? We get x cubed. X squared times minus 5, minus 5x squared. And now we move on to the 2. So we do 2 times that. So 2 times x is 2x squared. 2 times minus 5 is minus 10x. Now we move on to the 3. So minus 3 times x is minus 3x. Minus 3 times by minus 5 is plus 15. All right. Now let's collect all the like terms here. What do we have that are alike? So we have minus x squared plus 2x. we have minus 10x minus 3x. All right, so we have x cubed on its own, that has no like terms, and then we collect the x squareds together, so that gives us minus 3x squared. Collect the x's, which is minus 13x and plus 15. So that's your full and final answer. All right, question 13. An expression for the nth term of the sequence of triangular numbers is n bracket n plus 1 over 2. Prove that the sum of any two consecutive triangle numbers is a square number. So that the sum of any two consecutive triangular numbers is a square number. So this is a triangular number that we've been given. We just need to find the next one. Okay, what's the triangular number after that? Okay, just in case, a bit of background here, you might need to know if you haven't come across triangular numbers. Triangular numbers are what? The first one is 1, and then how do we get the second one? Well, we just build those triangles like that. So the next one is 3, and then you build another triangle. So you have 3 numbers on the bottom, and this one continues, and that gives us 6. And then you have the next one. So you have this one already, and you draw another layer here, so 1, 2, 3, 4, and that would be 6 plus the 4, which is 10. Okay, and then you saw what we did. You can see the difference each time. The difference starts increasing, so plus 2, plus 3, plus 4. What do you think this is going to be? Plus 5. The next one, plus 6. So you can see what we're doing. We're adding 1 to the difference each time. Okay, so we add 1 to the difference each time. So that's triangular numbers. Because what I'm about to do now, some of you will need to see this so you can understand it better. All right, so step number 1. If n bracket n plus 1 over 2 is a triangular number, okay, this is a, let's say, a triangular number, the triangular number after that would be, how do I find the triangular number after that? I add 1 to the difference, okay? I add 1 to the difference. So therefore, what I'm going to do here, I'm going to be adding 1 to the n, okay? The n. So the first n right here, I'm going to add 1 to that. So it's going to be n plus, let's do that in another color actually, plus 1, okay? I've added 1 to this n right there. Okay, now I'm going to add 1 to that n as well. Okay, that's going to be n plus 1. Okay, and this one already has a plus 1 as well, so don't get confused when I do this next part. Okay, I'm going to just close that bracket first, and then I'm going to add that 1, so you don't get confused. All right, that's going to be over 2. So this right here, what I've just done here, is my next triangular number. Okay, my next triangular number. And how do I find it? I just added 1 to each n right there. Okay. Now, if I just simplify this, okay, and I'm going to be adding them together, so I'm going to be summing them, so I'm going to add them together. So here we go, big add right there. So I've got n bracket n plus 1 over 2 plus, and I'm going to simplify this. Okay, so I can start by simplifying that first. So that's n plus 2. Okay, I can collect those together. So n plus 1 and then n plus 2 over 2. So this is the simplified version of the second consecutive triangular number. So this is the first one, and this is the second one. I'm going to be adding them. Right, now I've got the same denominators, so I can just collect the top together. So if I expand the each bracket, so I have n squared plus n, that's this one right there. And then the next one would be expansion of double brackets, so it's going to be n squared plus 2n plus another 1n, so that's 3n plus the 2, okay, and that's all over 2, okay, that's a common denominator. Collect all the like terms now, so I have n squared and n squared, which is 2n squared, and n plus 3n, which is 4n plus 2, all over 2, and then I can cancel by 2, I can divide everything by 2, because 2 is a common number here. So that becomes 2, these are 1. So that becomes n squared plus 2n plus 1. Okay, that's my final answer right there. Now, remember the question. Okay, the question is that I have to prove that the sum of any two consecutive triangular numbers is a square number. So I've got this thing here. How do I do that? Well, if you look at this carefully, if you can factorize out like that, you can have one there, plus and a plus. That's basically factorize. And then you've got two brackets which are the same and you're squaring them. So there you go. That's your proof that it's a square number. Because whatever's inside the bracket doesn't matter. When you square something, that becomes a square number. All right. Question 14. OAB is a triangle. OBC is a sector of a circle with a center O. Calculate the area of OBC. So OBC is all of that. Okay, that's what we need. Now, if I draw this out real quick, OBC, we have the angle here. And how do you find the area of a sector? Area of a sector is theta over 360 times pi r squared. And r is basically that radius, which we don't have. But we can find it by using this triangle right there. Okay, we can find that radius. Once we know it, we can come back to this and calculate the area. All right, so step number one, we are going to use the other triangle. All right, let's draw that out. That's O, that's A, that's B. That's 9 centimeters, that's 35 degrees, that's 6 centimeters. And we are going to find BO, B2O. Okay, how do we do that? The cosine rule. Okay, we're going to need to use the cosine rule. So this would be A, that would be small a, that's B, and that would be small b. And usually this is C, all right? So let's just get rid of that and call that C and call that C. It doesn't matter, by the way, if you get rid of letters. At the end of the day, they're just for your working out, okay? All right, so we have A squared is equal to B squared plus C squared minus 2BC cos A. Okay, this is the one that you need for calculating the lengths. Right, so A squared, what's A squared? That's my x squared, or BC or BO, whatever, yeah? B is 6 squared plus C is 9 squared minus 2 times 6 times 9 times cos the angle, which is 35. If we calculate that now, so if you have x squared is equal to, all right, be very careful, do this separately. Okay, do this separately, take them away, be careful when you're doing this. You should get, I'm going to quickly fast forward here, so 28.53157922. If you did not get this, go back and check this. You probably haven't done this correctly, okay? So go back and check this. Now to square root that, so I square root the answer, I get 5.34 centimeters, that's to 2 decimal places. So 5.34 is our length right here. Now I can go back to this and add it here because this is the same length. So now I have this diagram for stage 2. So part 2. So now this is 5.34 centimeters. I have my radius, so therefore the area of our sector would be theta, which is 80 over 360 times pi times 5.34 squared. And if you put that into your calculator, you should get 19.9 centimeters squared, and that's to 3 significant figures. Question 15, factorize a squared minus b squared. This is the difference of two squares. So a, b plus minus. Goodbye, let's move on. Part B, a bit more challenging than the first part. Show that 2 to the power of 40 minus 1 is the product of two consecutive odd numbers. So show that it's a product of two consecutive odd numbers. Now, if we use, this is why the earlier part was done, okay, to hopefully jog your memory about these things. We can look at this the same way, okay? How so? If we factorize, or try to factorize in the same way, we have the 1 and the 1, that's easy. Okay, 1 times 1, a square number. Okay, that's no problem. Now with that, what do? We put a 2 there. But remember the powers. What do you do with the powers when you're multiplying powers? So if you have 2 to the power of something times 2 to the power of something, what do you have to do to the powers? We've done it earlier in one of the questions. You add the powers. And you need to add the powers to get yourself a 40. So what do you think they need to be? The powers here, 20. Okay, they need to be 20. because 20 plus 20 is your 40. And it's a difference of two squares, so you can give one of them a plus and one of them a negative. It doesn't matter which way around, by the way. Okay. Right, so that is that factorize. So now, what do we do next? Right, so look at this. This number here, same number, right? One of them is adding and one of them is taking away. What is this number, 2 to the 20? What is 2 to the 20? Is it an even number or an odd number? So 2 to the power of 20 is an even number. You can check this on your calculator, all right? So 2 to the power of 20 is an even number. It is equal to 1048,576. It's a calculator paper. You can check that as well. All right, that's probably the easiest way. And look, this number here is an even number, so it's an even number. Now, what are you doing next? You're doing an even plus 1, which gives you an odd number. On this one, you're doing an even, take away 1, which also gives you an odd number. So you now have two numbers which are odd. This is odd and this is odd. You are multiplying two odd numbers. So that's the product. To multiply is a product. All right. So you're doing an odd times an odd. The product of two consecutive odd numbers is equal to 2 to the power of 40 minus 1. Because remember, this came from that. So it's equal to that. And there you go. Question 16. On the grid, enlarge the triangle T by a scale factor of -2 with the center of enlargement -2, -2. Right, so just be careful with this one. Negative right there. Okay, the scale factor is a negative, which means you do the opposite. So if it's going forward, you go backwards. If it's going up, you go down. Okay, I'll show you what I mean by that. Anyway, the center of enlargement is -2, -2. So let's go mark -2, -2. -2, -2. So this is where it's all being done from. Okay, right there. Right, let's take a point. It's probably the easiest way. I'm going to take this point. This point currently is 1, 2, 3, 4 away. Okay, 4 away. There's no up and down. So now it's -2, scale factor of -2. So I'm going to go backwards the opposite way. But this 4, I'm going to times it by 2 first. So it's going to be 8. So I'm going to go backwards by 8. 1, 2, 3, 4, 5, 6, 7, 8. It's right here. I'm going to mark it right there. Okay, that's my fact. Let's do it across there. Okay, that's that. That's my point. And I can do that with the others as well. So this one right there. So look, I could do 1, 2, 3. So 3 down, 1, 2, 3. 3 across. Times by 2, everything. Okay, so 3 is going to be 6. And 3 here is going to be 6. So instead of 3 down, okay, I'm going to go 3 up. I mean 6 up. 1, 2, 3, 4, 5, 6. And I'm going to, instead of going, remember I was there and I went that way. Now I'm going to go that way. So from the top, I'm going to go that way. So by 6. 1, 2, 3, 4, 5, 6. Right here. That's my marking right there. So there we go. And I can do that with the last one, or I can just, just work the triangle out, which you can do, but I'll just show you the last one, okay? So here's my last point. So 1, 2, 3, 1, 2, 3, 4, 5. So 3 is going to become 6 up, and 5 is going to become 10 to the right, okay? So 1, 2, 3, 4, 5, 6, and then 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right here, okay? And now I can just go and join my triangle up with straight lines. My points up with straight lines, okay? And then look, you could do this little check here. Every single corner, go and find its corresponding corner. So this one was there, and you should see that they magically go through that center of enlargement right there. And that's how you know that you've done everything correctly, okay? And this is clearly been enlarged by 2 as well, just in the opposite direction. Question 17. Here is a distance time graph. Find an estimate for the gradient of the graph at time 2.5 seconds. You must show how you get your answer. Right, so gradient means to draw a tangent line at 2.5. Let's go and find 2.5 first. So right here is 2.5, exactly for the time. And I just need to draw a gradient. Okay, I just need to draw a tangent, I should say, and find the gradient. So I just need to draw the tangent now. So it can be anyhow, guys, here, not too much obviously you don't want to cut the line too many times, you just have to do it once. Okay, right there is all right. Sometimes the slant might be different, and that's why it's an estimation. Okay, it's just it's an estimation. Right, so let's go for that one. All right, I'm just gonna, oh, that actually went a bit heavy. Let's do that again. Went a bit too heavy for my liking. Let's do that. That's better. Okay, right, that's all right. Right, so what do I do now? I just basically find points, nice points that I can use to find the gradient. Can't really see anything going in the corners, but yeah, let's do that one. So that's all right. I'm gonna draw a triangle there, and let's go up to that. That's all right. Okay, so what am I doing here? I'm just going from 2 to 3.5. Okay, so what's the distance here? 2 to 3.5. That's 1.5. Okay. Right here, am I going from here? I'm going from, what is that? Okay, I have to work this out now. So 12, 14, 16, 18, 20. Yes, that's 12. All right, that's 12. And I'm going up to 38. So 12 to 38, you can work that out. You can do 38, take away 12. That is 26. That's 26 right there. So now to work out the gradient, that's m is equal to y divided by the x. So that's going to be 26 divided by 1.5. So 26 divided by 1.5, and I'm getting 17.3 recurring. Okay, just leave it at 17.3. Remember, at the end of the day, it's an estimation. So 17.3 is the estimation. How I got my answer, the examiner can see I've drawn my tangent, I've drawn a triangle underneath, I've done this working out, and you'll have a range, by the way. So in the exam, your range will be something around these values. Let's go 16.5, 19.5 as per the mark scheme. All right, what does the gradient of the graph represent? You have to give the context here using distance and time. Okay, so what is distance and time? If you're doing distance divided by time, which is what you're doing, look, that was a distance, wasn't it? Yeah, the distance, and you're dividing it by time. Distance divided by time, what is that? Distance divided by time is equal to speed. So the gradient represents speed. All right, question 18. A solid frustum is made by removing a small cone from a large cone as shown in the diagram. If you're an IGCSE student, usually you don't need to worry about frustums. Okay, so yeah, you just need to work out the volume of the entire thing and not worry about frustums, just for any IGCSE students watching. Right, the slant height of the small cone is 6 centimeters. The slant height of the large cone is 10 centimeters. The radius of the base of the large cone is 3 centimeters. Calculate the total surface area of the frustum. Let's highlight that. So that's what we're trying to work out, the total surface area of the frustum. So the frustum is this part here. Okay, we're trying to work out the top and the curved part, the area of that. Give your answer correct to 3 significant figures. All right, look, how do we find that frustum? All right, we do the big one, the big cone, this one, and we take away the little cone, and that leaves us with the frustum. Okay, that leaves us with the frustum. So let's draw this, yeah? So we've got the big cone, that is 3 centimeters, and we've got the small cone, which we don't know. Actually, that looks too big there. All right, so we don't know the radius of the small cone. That's what I was saying. We don't know the radius of that. Right, the small cone is 6 centimeters, as it says right there, and the large cone is 10 centimeters, as it says there. All right, this side, that side, same. Okay, so we're trying to work out the radius. We don't know what the radius is. These are 2 similar shapes because they came from the same object. Okay, same cone. So we can work out the scale factor by using these 2 sides. So if we do 10 divided by 6, that gives us 5 over 3. Don't round, okay, because with scale factor, if you start rounding, it would mess up your overall answer. And then we can find the radius, which is also a length. Okay, we can find the radius by doing 3 divided by that. Okay, so 3 divided by 5 over 3 gives us 1.87. centimeters. Okay, be very careful if you are going to put this into your calculator. Make sure you use the fraction button for that. Okay, right, so 1.8 centimeters is the radius of our smaller cone. So we can put it here, right there. Okay, 1.8 centimeters. Now we can go and find the surface areas of our large cone and the small cone. Okay, so let's write it here. So surface area of large cone. Okay, now the formula for surface area is right there. Okay, it's the curved part. So we're going to work out the large cone, the curved part right there, plus the bottom. Okay, but for this one we won't work out the bottom. Okay, and I'll explain why later. So pi RL, so pi times r, which is 3, times the length, slanted length, which is 10. That is the curved part, plus the circle. Okay, plus the circle. So that's going to be pi times radius squared, right there. Okay, that gives us 122.52 ... centimeter squared. So I've just put that into the calculator, added it to that. Okay, that's that. Now the small cone. Let's look at the small cone. So the surface area of our small cone. Now, it's not required to calculate the circular side now. Okay, why? Look, the small cone, if you look at the small cone, you don't need to work out this because you're not seeing it right now. Imagine lifting that off. You don't need to worry about the circular side that's leaving it. Okay, because it goes with the cone. We'll work it out separately. Okay, we'll work out that circular part separately because we're going to know its radius. All right, so we don't need to worry about it for now, just for the surface area. Okay, because it's not visible anyway. So not required to add the circular side now. Okay, you don't need to do it now. That's the difference. Okay, because if you do it now, you're going to be taking away too much. All right, that's why. All right, so now what do we have for the small cone? Pi times radius, which is 1.8, we worked out, times the slanted length, which is 6. Okay, that gives us 33.929 ... centimeter squared. Now the frustum. To find the frustum's surface area, we are going to do 122.52, which is the large cone, take away 33.929, and then we are going to add that circular part. Remember, I said to you that we're going to add this. So once this goes, this cone goes, all right, it leaves this circular part, and we're going to need to add that after we find the surface area. Okay, we're going to add that there. So what is that, by the way? That would have the radius of 1.8, just like the small cone. Okay, and we'll just find the area of that. Okay, so that's going to be plus pi times 1.8 squared. All right, now let's do that calculation, guys. Okay, so be very careful here. We're going to do this part first, then add that. Okay, so let's do it in steps. So 88.5907 plus what we get from that, which is 10.1787. And now if we collect that together, we get 98.76946. And that can be rounded to 3SF, as the question mentions, to 98.8 centimeter squared. And there you go. That is your full and final answer. All right, question 19. Sana needs to draw the graph of y is equal to 3 to the x. Between that, she draws the graph shown on the grid. Write down one thing Sana has done wrong for 1 mark. Okay, what's she done wrong? Right, that's an exponential graph between 0 to 4. Let's see what she's done. Right, guys, you know when, if you notice here, look, the graph is y to the power of 3 to the x, right? She has substituted a 0 in here as your x value, okay, as your x value, and she got the y value to also be 0. Okay, let's see if that really happens though. So when x equals 0, is equal to 3 to the power of 0. But what is 3 to the power of 0? It is 1, all right? But she's made it y is equal to 0 right there. It should have been higher. Point 1 is right there. So her graph should have started from there and gone up like that. Okay, should have started on 1 because that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, of course. Okay, so that's where it should have started, not on 0. So that's one thing she's done wrong. So graph should begin at y equals 1, not y equals 0. Or you could say something like graph should begin at 0, 1, not 0, 0. Yeah, there you go. All right, question 20. Prove algebraically that 0.12323 recurring can be written as that. That's basically recurring decimals. So where do we begin? Let's say x is equal to 0.12323. Remember, it's a 2 and 3 that are recurring. So what's the aim here? The aim is to get up to that decimal point, the recurring parts only, which is a 2, 3, 2, 3. Okay, so that 1 needs to jump over here. But we need to also think about taking something away afterwards. So it's better that we do 1,000, because then we'll have the 2, 3, 2, 3 again repeating. So we take all of that over by doing times by 1,000. So we say x, 1000x is equal to 123.2323 dot dot dot. And then we can have a 10x. Okay, so 10x would mean that the 1 jumps over here, the 2 would go there, repeating the 2, 3, 2, 3. So 10x would be 1.2323 dot dot dot. Okay, now we can take them away. Okay, we can take them away. So what do we have? 1000 take away 10 is 990x. We can take that away, we get 122, and of course these cancel. Okay, so we get 122, and then x would be equal to 122 over 990. But it doesn't look like that yet. So how do we get it to look like that? Well, simple. We just find something that divides both. If we divide by 2, 122 divided by 2 is 61, and 990 divided by 2 is 495. And there you go, we've proved it. All right, question 21 for 4 marks. Solve that. All right, we can have a same fraction here, one fraction here, and then we can multiply the denominator to the other side and then solve it from there. Okay, shall we do that? So cross multiply, that multiplies up there, that multiplies there. So it becomes 1 bracket 2 minus 2x plus 3 bracket x plus 4, and all over x plus 4 and 2 minus 2x equals 1. And we're going to, of course, take all of that and multiply with that 1 on that side next as well. So before we do that, or while we do that, we can expand these out and expand these out as well. So we get, what do we get? We get 2 minus 2x plus 3x plus 12, and take that over as well. So times by 1. I'm not going to keep the 1 there, guys, because we don't have to write it out. So x plus 4 and 2 minus 2x. Okay, there we go. Right, collect the like terms on this side. We have 2 plus 12, which is 14, and plus x, and then expand these brackets out here. So what do we have here? We get 2x minus 2x squared plus 8 minus 8x. Right, let's take everything over to one side now. All right, I'm going to move all of this over to this side. Why? Because I want to have x squared as positive. So if we take everything over to one side, we have 2x squared plus 7x plus 6 equals 0. And then we factorize that. So let's see if the quadratic factorizing works. So that's 2x, x, 6 we want, so we can have 2 and 3 plus and plus. There you go, it works. So x is equal to minus 3 over 2, or x is equal to minus 2. So these are our two solutions for x. All right, question 22. Given that the vector a26 plus b82 is parallel to that vector 13,6, find an expression for b in terms of a. Right, so let's first of all put these in. Okay, so we're going to put them in together. So we have 2a over 6a plus 8b and 2b. Okay, so that is equal to or parallel to that vector with a like a k, a constant we need to use. Okay, so 13, 6. Okay, there. Then what we can do is also include that. So we can have 13k and 6k. So now we can collect these and these together. So we can have 2a plus 8b and 6a plus 2b. So this is equal to that, and this is equal to that. Let's write that down. So 2a plus 8b is equal to 13k, and 6a plus 2b is equal to 6k. Okay, let's solve this. Right, what we have to do is find a way of solving them simultaneously. So let's take this one, because we can divide everything by 6 here and make k the subject. So we can have, if we divide everything by 6, divide by 6 here, divide by 6 there, we'll have a plus 2 divided by 6 is a third, so a third b is equal to k. Okay, and then what we can do is take this k value and sub it in there. All right, so we can take that k value and sub it right there. All right, so we can sub it right there. So therefore 2a plus 8b is equal to 13 bracket a plus a third b, and that's it. So that's your k. Okay, right, let's expand that bracket. So we have 2a plus 8b is equal to 13a plus 13 times 1 over 3, which is 13 over 3b. And then collect the like terms on one side. So take the 2a over to that side, giving us 11a. Take 13b to the other side. So we can use a calculator, so we don't have to worry about this fractions. So 8 minus 13 over 3. That gives us 11 over 3b. And what we can now do, let's just go back to the question. What was the question? Oh, find an expression for b in terms of a. Okay, so we want to make b the subject. So times by 3, so we have 11b equals 33a, and then divide by 11. So 33 divided by 11, that's 3a. And there you go. I found an expression for b in terms of a. Question 23. A circle has the equation x squared plus y squared equals 25. The point P with the coordinates minus 3, 4 lies on the circle. Alex says that the tangent to the circle at P crosses the x-axis at the point minus 8, 0. Is he correct? You must show how you got your answer. All right. A quick diagram would really help in these situations. So if this is your circle, 0, 0 is your center, because it's right there anyway. GCSE, you don't need to worry about the radius. The center anyway. Right, and then it says the point P with the coordinates minus 3, 4 lies on the circle. So if we just estimate where that could be, let's just estimate it somewhere here. This is our point P with minus 3 and 4. And Alex says that the tangent to the circle at this point, so there's a tangent to the circle right there, and Alex is saying that it touches the x-axis, it cuts the x-axis. So Alex is saying that if you imagine this to be a graph right there, that this right there, this point is minus 8, 0. Okay, this is what Alex is saying. Is he correct? Well, let's find out. Let's find the equation of this tangent, and we are going to substitute, x equals minus 8, and let's see if it gives y as 0. That's the easiest way to do it. Okay. So how do we find the equation of the tangent? Y equals mx plus c, of course. We're going to use that. So we need a gradient. How do we find the gradient? By finding the gradient between 0, 0 and 3, 4, and then doing the negative reciprocal, because the tangent is perpendicular to the radius. Right, so let's find that first. So we're going to call it m1. So m1 would be y2 minus y1 divided by x2 minus x1. Okay, so that would give us m1 would give us, let's do 4 minus 0 over minus 3 minus 0, which is 4 over minus 3. So therefore, the gradient of m2, the tangent, would be the negative reciprocal, which would be a positive 3 over 4. So now, the equation of the tangent so far. The equation of the tangent so far would be y is equal to 3 over 4x plus c. I now need to find the c by substituting the point that the tangent goes through, which is minus 3, 4. So I'm going to sub minus 3, 4. So therefore 4 would be equal to 3 over 4 times minus 3. So I'm subbing the x and the y here, plus c. So we've got a calculator to use throughout, guys, which is very lucky. So it's minus 9 over 4. We don't, not for that though, yeah? By taking the 4 plus 9 over 4 to the other side. And that gives us c equals 25 over 4. So that's c. So the equation of the tangent is now 3 over 4x plus 25 over 4. Now, I just need to check if minus 8, 0 is a point on that line. If it is, then the point is on the x-axis. It crosses the x-axis at that point, okay? But let's see if it's a point on that line at all. So x is equal to minus 8. Let's sub it in. So y is equal to 3 over 4 minus 8 plus 25 over 4. What does that give us? It gives us 1 over 4, not 0. So minus 8, 0, not a point on the tangent. So therefore, if it's not a point on the tangent, it's not a something that the tangent doesn't go through the x-axis at that point. All right, last question, question 24. There is a total of y counters in a box. There are x pink counters and 5 blue counters in the box. The rest of the counters are green. So the rest are green. And we've been given the ratio of x to y as 1 to 3. So x is 1 and the y is your overall total. That is y counters. All right, Freda takes at random 2 counters from the box, finding in terms of x an expression for the probability that Freda takes 2 counters of the same color. Gives you answer the fraction where a, b, c, d and e are integers. Right, very, very wordy. So what we're doing, we are finding in terms of x an expression for the probability that Freda takes 2 counters of the same color. Wow, where do we even begin? All right, let's see. Let's break this down. Number 1, we are told that there are y counters in a box, and then we are told that the number of pink counters compared to the overall amount of counters is 1 to 3, which means what? It means that there are 3 times as many counters as x or pink counters in the box, yeah? As pink counters in the box. Okay, so what we can say is that y is equal to 3 times x, or we can rearrange that as x is equal to 1/3 of y. So therefore, if x is equal to y, remember that's pink, okay? So pink is our x, all right? Pink is our x. Blue, what does it mean for blue? What do we know about blue? Well, we know that there are 5 blue counters. So there are 5 counters which are blue. And the rest of the counters are green. Okay, so the rest, which is green, the remaining. Okay, so the remaining of what? Well, all probabilities are of 1. So 1, take away the x, take away the blue. Okay, so the x is a pink. Okay, that's the green. That's the representation of the green. Furthermore, what we can say is that the 1, which is what all the probabilities are of, can be represented as y itself, because y is all the counters. So y minus x minus 5. That can now represent green. Okay, that can be green. That is an expression for green now. Okay, so just go back over that if you didn't quite understand it. So pink is just x, or you can also represent it as that, okay, which we might do if we need to. All right, blue is 5 because there are 5 blue counters, and green was the rest of them. Okay, and the rest is basically to do probability 1 minus the x minus the 5, and the rest here, the total is y, so I replace the 1 with the y. Okay, right. Step number 2. What's step number 2? We want to take 2 counters of the same color. So what does that mean? That means I want to take a pink and a pink, so an x and an x. So let's just use pink and a pink. Or I want to take a blue and a blue. Or I want to take a green and a green. Okay, that's 2 counters of the same color. So if we focus on the pink and the pink, that is x over the total number of counters, which is y, times by the second pink now. So now I'll have 1 less pink, so x minus 1, over, and I have 1 less counter overall, so y minus 1. That is a probability of pink and a pink. All right, just get your head around that if you didn't quite understand that. So once again, I'll repeat it. X is the probability of a pink over the total number of counters, y. And the second time I go for the counter, remember it's non-replacement, I have got 1 less pink, so I take away the 1, and I've got 1 counter overall less. 1 counter less overall, I should say. All right, so that's that. Or means add. And now I'll do the blue. Okay, now I'll do the blue one. So what's blue? It's 5 out of the total, y, times 1 less than 5 is 4 out of the total, which is 1 less as well. That's blue. Or once again, and now the green. What's green? Now the green gets complicated, so be very careful. The first green is y minus x minus 5 over the total, which is y. Now the second green is y minus x minus 5 minus 1, because remember, you take 1 away from the total. Okay, and that's overall counter is y minus 1. Now, we are now going to simplify things. So all of this, if you notice, is one denominator, okay, the same denominator, and we are adding them. So I'm going to put one big fraction line and then one denominator, which is y minus that, because they're multiplying at the end of the day. All right, they're multiplying. On the top, these are multiplying. So x minus 1 plus 5 times 4 is 20. That's nice and simple. Now this one, we've got to be careful with that one the most. So that is the first one. The second one, I'm also going to take these away. So that's minus 6. So y minus x minus 6. And there you have it. Now, we need to expand. We need to expand all of that. So we've got x squared minus x plus 20. And now we have to expand that times that, that times that, that times that. You know the drill. Yeah, etc., etc. Okay. So I'm going to do that. Be very careful. I'm going to put it in a bracket as well, because I might get surprises. So y squared minus xy minus 6y. Now the x is minus xy plus x squared plus 6x. Okay. Now I need to make some room here. Right, so now I need to do the 5 times that, 5 times that, 5 times that. Okay, so that would be minus 5y plus 5x plus 30. All right, there, got it done. And then on the bottom, we still have y bracket y minus 1. Okay, I'll just leave that for now. I won't do anything here. Now I want to collect all the like terms. All right, so if we look for the x squared here, we've got another x squared here, and that would be 2x squared. We have we have minus x here and plus 5x there, and outside, by the way, be careful, this is not negative, so I don't have to worry about the signs changing inside. So minus x, oh hang on, I missed one, and then that as well. So I have minus x plus 6x, which is 5, plus 5, which is 10. So plus 10x. Next we have the numbers. So we can just do 20 and that, which is 50. And now we have our y squared. So we've got no y squared. xy, do we have any xy there? So xy 1, 2, right there, yep. So we have minus 2xy, and now minus 6y and minus 5y is left, so minus 11y. Okay, there we go. That's what you should have. Right, so here I am now, and let's just go back to the top and reassess what the question is asking us to do. This was very important. So it says, give your answer as a fraction in this form here. Right, I currently don't have that. Let me just make a copy of that so I can have it to look at. So that's what I want to do, yeah? Right, okay, so if you're looking at this, okay, I could consider completing the square on some of these things. Right, like this and then that and that when I put them together, but then I've got this in the middle. Let's just go back. So if you go back, there's some, right, remember y was equal to 3x, so I can get rid of the y's by substituting y as 3x. So if I sub y equals 3x, so wherever I see a y, I'm going to sub in 3x. So that's 3x there, 3x there, 3x there. Okay, let's do that. So therefore 2x squared plus 10x plus 50 plus 3x squared minus 2x and then 3x minus 11 and then 3x all over and then 3x minus 1. Okay, that's better. Now we've got everything in terms of x's, no more y's. So let's continue that mode. So now we get 2x squared plus 10x plus 50 plus 9x squared, that would give us 9x squared, and then minus 6x squared minus 33x all over 3, let's actually expand that too, so all over 9x squared minus 3x. Right, we've got to collect the like terms again. So we have that's 11 minus 6, which is 5, so 5x squared, and then we've got 10 minus 33, which is minus 23, so minus 23x, and then we've got 50, so plus 50, all over 9x squared minus 3x. And there you go. That's the answer that it wanted us to have. So our A is equal to 5, our B is equal to minus 23, so let's write them down. Our A is equal to 5, our B is equal to minus 23, our C is equal to 50, our D is equal to 9, and our E is equal to minus 3. And there's your full and final answer. Hope you enjoyed this lesson, and if you liked it, please do give the video a thumbs up. If you share the channel and subscribe yourself, then I can create more videos like this, because your support really helps me to create more content like this and support people through their GCSE and A levels. Goodbye for now, and I'll see you in the next one.